This is a tutorial on geometric sequences. A geometric sequence is just a sequence of numbers where each term is the previous term multiplied by some number. And every term in that sequence is always just the previous term multiplied by the same number. An example of this would be our first sequence here, 3, 9, 27, and 81. Now in geometric sequences, we're using multiplication. So to go from 3, our first term, to our second term, 9, by multiplication, we would have to take 3 and multiply it by 3. And that would get us 9. Now if we take 9 and we want to go to 27, we would have to take 9 and we'd also have to multiply 9 by 3, and we would get our third term, 27. Now if we take this third term and we multiply it by 3, we get 81, our fourth term. Now because each term is increasing by being multiplied by the same number, in this case 3, that means that this term here is indeed a geometric sequence. Now let's look at our second sequence here. We have 2, 6, 24, and 96. Well, to go from 2 to 6 through multiplication, we would have to take 2, our first term, and multiply it by 3 again. And that would get us 6. Now to go from 6 to 24, our third term, we would have to take 6 and we would have to multiply it by 4. So our third term would be 24, and if we multiply our third term by some number to get 96, that number also has to be 4, because 24 times 4 is 96. Now notice that this sequence, these numbers are not being multiplied by the same number each time. So this sequence here is not a geometric sequence, because first we multiply by 3, but then we multiply by 4. And for it to be a geometric sequence, this has to be the same number each time. Now when we have a geometric sequence, we can write a formula for that sequence as either a recursive formula or an explicit formula. And if it is a geometric sequence, then there's a standard form for both the recursive and the explicit formula. Now here we're back at our original sequence, 3, 9, 27, and 81. Again, each of these numbers is the previous term being multiplied by 3. So first let's look at our recursive formula. Here we have a to the n, or the nth term, or some term in our sequence, that's always equal to the previous term, n minus 1 term, times r. R is what's called the common ratio. The common ratio is just the number that you keep multiplying each successive term by. So in this case, our common ratio is 3. So a recursive formula for our geometric sequence is just every term is the previous term multiplied by the common ratio. And the recursive formula for this geometric sequence would be that our nth term is always the previous term, or the n minus 1 term, times our common ratio, which in this case is 3. If you want to simplify this a little bit, our nth term is always 3 times our n minus 1 term. Now let's talk about the explicit formula. Remember, explicit formulas don't include previous terms generally. They include the n value, or the position of our term. The explicit formula for a geometric sequence is that the nth term is always the first term times our common ratio again, which is r, but this common ratio is put to an exponent, or has an exponent of n minus 1. This geometric sequence that we're given, 3, 9, 27, and 81, we know the common ratio is 3. Our first term, or a1, that's also 3, because our first term is 3. So we can write the explicit formula for this geometric sequence as an is equal to our first term, 3, times our common ratio, which is 3, to the n minus 1 power. So if that's our explicit formula, we can test this out. If we wanted to find the fourth term in our sequence, which we know is 81, that would be A4 is equal to 3 times our common ratio, which again is 3, to the n minus 1 power. Well, we're looking for our fourth term, so n is 4, so this would be to the 4 minus 1 power. So our fourth term then is just 3 times 3 cubed. Now 3 cubed is 27. And 27 times 3 is indeed 81. So our fourth term then would be 81, which we know it is. So that's how you can write recursive or explicit formulas for a given geometric sequence. Now the last thing we have to talk about is the geometric mean. The reason why we have a geometric mean is for geometric series or sequences. If we need to find a missing term in a geometric sequence, we can typically use the geometric mean. Now you may know about the arithmetic mean, but arithmetic means don't work for geometric sequences, and let's see why. If we call the x-axis here the n-axis, or the position of our sequence, and then the y-axis is the value of our terms, so the nth term axis, then we can plot our sequence 3, 9, 27, and 81. Our first term is 3, and that would be roughly right about there. Our second term is 9, and that one would be roughly there. Our third term is 27. That would be about there. And our fourth term is 81. And that would be way up here. Notice that these terms are following the shape of an exponential graph. Now let's say we didn't know our third term. And we wanted to find this third term. All we knew is 3, 9, some term, and 81. Well, if we tried to use an arithmetic mean to find this term on a geometric sequence, between 81 and 9, we would find that our value would be, roughly here. And this is about 41, 42. But since this is a geometric sequence, that would be incorrect. So instead, to find our missing term on a geometric sequence, we use what's called a geometric mean. And the geometric mean is kind of like an arithmetic mean. Instead, we take our two terms that are on either side of that missing term, so in this case 9 and 81, and we multiply those numbers together. If we multiply 9 and 81, we would get 729. Then we take the square root of that multiplication, so the square root of 729. And if you take the square root of 729, you'll get 27, which is what we were hoping to find. So if you have a geometric sequence and you're missing a term, you have to use the geometric mean to find that term. So let's practice this again. Here we have 24, a missing term, and 96. Well, the geometric mean tells us that if we want to find this term, we take the terms that are on both sides of it, 24 and 96, and we multiply them together, and then we take the square root of that multiplication. Now 24 times 96 is 2,304. If you take the square root of 2,304, you'll get 48. So our sequence then would be 24, 48, and 96. So that's how you can use the geometric mean to find missing terms in a geometric sequence. And that completes the tutorial on geometric sequences.